Bonjour, je suis Florian, and sorry for my bad French, and that's already at my limit. Welcome to the talk today and having us. And I have the pleasure to talk to you about universal profiling. So as a first start, who already uses universal profiling? I want to see more hands. That's why I'm giving this talk. Who already knows about universal profiling? A little bit more hands. That's great to see. So first about myself, I'm Florian. I'm a software engineer at Elastic, and I'm working on the observability, eBPF, and Go team. And we are the team that is building the universal profiling agent and bringing all the nice features to you. What are we talking about in the next few minutes? I don't want to talk too much on slides, and I will have a big focus on demos and show you how you can interact with everything. So at the beginning, I will talk about what are the problems we are trying to solve with universal profiling, what is universal profiling, and then the big part of the presentation tonight is about the demo, how you can interact with Kibana, with universal profiling, how you will dive into the data and can get the best out of it. So universal profiling, we have a lot of use cases. One of them is SRE, and that's our big focus. If something happens in your infrastructure, you want to see what is happening there. With current solutions, you always usually focused on one application, but you don't know what's happening next to the application. So if there's something running on your environment that you maybe don't know or not aware of, we will tell you about this. As a next user, everyone has to pay something. Budget is limited, as we noticed today. Everyone wants to know how do we spend money and where do we spend money. And I think nowadays this becomes more and more important that we know and can break down the information. Where do we spend our money? I think if you ever looked at a bill that you get from a big cloud provider, they just say computing, storage, and that's it. And then there's a big number. But having a more detailed information about, hey, what are the applications that are most expensive to myself? And is this the application I have my business case or building my OKRs on? Then I want to know about this. And last but not least, for me, that's a personal important topic. As a developer, I want to show to my boss and to my teammates, hey, I'm this good. I improved the application this far. And that's why you should promote me, myself. So these are the 3 people roughly that you can think about that can be interested and should be interested in universal profiling. So how does everything work? It's quite easy. We're using a technology called eBPF. So all I'm talking about is really focused on Linux deployments. If you're running on a Windows setup, it might not work today. I have to ask for your patience. So everything I will talk about today is really about Linux focused. It will also not work on OS X as a concept. And we have some eBPF bytecode in user space with an agent that we load with an BPF syscall that is specific to Linux. And with this bytecode is basically passing a verifier in the kernel. And if the verifier accepts our bytecode, then the bytecode will be cheated in the kernel. So it will become even more performant and will be translated to native code on the host and will be attached to various Linux kernel events. eBPF itself is really event focused. It's not a program that runs in kernel space that is running all the time. It's really just triggered on events that are happening on the kernel side. As Kubernetes is happening this week, I think it's super interesting. Where do we see this everything happening with Kubernetes? And in the Kubernetes world, you have pods, you have containers, but they are separated in various ways. But they have one thing in common. The one thing in common is they use the very same Linux kernel. And so we can attach to these various events and can differentiate these different pods, containers, and don't need to run in every pod or every container to get all the information that is running on the system. So we have a whole system view and don't need to apply or do something to every application. A more detailed slide, what is happening on our side. So there's a universal profiling agent that you can deploy with Elastic Agent, Helm charts, and other ways that embeds an eBPF bytecode. And the eBPF bytecode is then loaded into the kernel with the verifier, as I said. And then with the JIT compiler, it comes really down to the host architectures and how the host architecture instructions. For universal profiling, at the moment, we are supporting x86 and ARM64. So depending on where you run your applications, we both, I think these are the most common used CPU architectures. As universal profiling is a sample-based approach, we are attaching to perf events. Perf events itself, or perf itself, is a subsystem of the Linux kernel that allows us to have a constant sampling rate. So universal profiling is using 20 hertz sampling rate. So we are triggered in this constant way, and every time we are triggered, we are basically walking the stack that is currently on the CPUs and pushing all this information via eBPF maps 3 and 4, in this case, to the user space. In the user space, we cache then everything and compact it and send it via within gRPC protocol back to the Elastic stack. So currently it's so that in the integration server, there's a specific universal profiling collector that can receive this protocol information and then writes that directly the information into Elasticsearch, and with Kibana you can inspect and view all the data. If you have any question, and if I'm talking too fast, please interrupt me, raise your hand. I'm super happy to answer questions. So that's why I'm already at the demo. I think I'm talking quite fast. So I think that's the view most of you people should know. If I open, is this fine for the size for everyone? Okay. For the setup, for the demo today, what I've done is I did get an Azure Kubernetes account. On this Azure Kubernetes account, I deployed the OpenTelemetry demo application and the universal profiling application. And that's it. I have done nothing more. And that's also the entry point with Kibana that we can see. And if you open the menu, we are part of the observability stack. You have on the left-hand side universal profiling. And here we can click. I would just interrupt here. So these are the ways you can install universal profiling on your environment. We support Kubernetes with Helm charts. We have Docker images, binary. You can also directly use the binary. DVM packages, RPM packages for Fedora, and we have an Elastic Agent integration. So it's really up to you how you want to integrate universal profiling in your environment. And then the first thing you will see, basically, if you're opened universal profiling, is a lot of stack traces. From this view itself, I think it's hard to tell what is happening. You get a feeling, hey, there's a lot of stuff is red. There's a lot of stuff that's coming up in a frequent way, maybe. But this view can give you a nice overview. And I did set up everything on Friday and did not touch anything because weekend. And but now I'm looking at for the first time since Friday on this data. And the first thing I notice just is what happened just around this time. I have a big spike. So something happened there, and I just can zoom out a little bit. I know okay, I can just tell, hey, here LS hardware is running. So it looks like to me, I have really no idea about the environment that is running in, but I just can tell from this flame graph, hey, there someone or something or some service was running LS hardware. So looking at the hardware specification of the Kubernetes environment, I don't know who triggered it and why it was triggered. Maybe some Azure technique or API that was triggered and using this executable, but that's already the insights I get without doing anything. And I think that's the fun part. You see all the stuff that you don't usually see. And then when I scroll down, we get a top view with the applications sorted by the most expensive application to the least expensive application. And here we see already Kubernetes, kubelet. All the environments I'm looking at in Kubernetes, kubelet is usually one of the most expensive applications. That's a fact, unfortunately. But then we already see WRK Worker 1 and WRK Worker 0. These are part applications from the OpenTelemetry application. So they spend roughly 13% of CPU time. And then container orchestration with containerd all in one is also, I think, part of the OpenTelemetry. Product catalogs, currency service is also part of OpenTelemetry. So I really get a nice overview what is running on my system without having to know really logging into the system, getting an overview. That's really a handy overview. We can also tell coming down to the hosts. So at the moment, I just have a free AKS account. So there's just one host. We extract also the cloud metadata, and that's why we can break down all the information. So that's the host name. I think if you go down in some Azure environment and look up this name, you will find more information how this host looks like. Deployments, I just have the hotel deployment. So we have a special part, basically, I would say, in this. Here we see other with 40%. Other is the component that we combine everything, where we say, hey, we did see it, but we did not see it often enough that it was ranked high enough to become in the top 21. So everything is brought together, and you have to zoom in maybe from the time view more to get a more detailed view. But here you can already see, hey, my front-end proxy is the most used deployment. There's Kafka, there's Jaeger, currency service, product service, product catalog service, coordinates. So the usual Kubernetes components that come with a Kubernetes application. And last but not least, we can tell you also, not open a new tab, we can tell you also more about the containers. So here we have the special order together as well, because order can represent here the host itself, so the node that where everything is running on. And but we have the containers like the front-end proxy, Kafka, Jaeger. So you can really drill down all the information, how your system is look like, and how everything comes together. So there's also a metrics server, a Prometheus server coming with the OpenTelemetry demo. That's so super interesting. If you are in the field of profiling, you probably heard already of flamegraphs, and of course we can do this as well. Now I just have a little bit of zoom issue. It's I'm trying to cheat. So you will not be able to read everything that is written in every line, but I just want to give you a feeling. On the right down side, you have a little overview where you are in the flame graph, but that you can already see, hey, there's Envoy running on the system, which is costing me most of CPU time. There's kubelet, and there is already some Java application. So please keep in mind at this point, I didn't do any instrumentation or extraction. But if you look closer, and I hope I can zoom in a little bit, or you trust me, we walk the stack, and we extract also the symbols information. So in this case, it's Java. So you did see a lot of different colors, and we color encode depending on the language. So the more purple-like style is the kernel. The more bluish frames are more native code like C, C++, Rust, and Go. The green ones are for Java. The more orange style ones are for Python. And I don't remember every other color, but there are more. There's also a color for Perl. There's a color for Ruby. So if we zoom out again, we will see a little bit more colors. And as you can see from this graph already, we really walk all the stack from user space up to the kernel space. And that's really impressive, I would say. Going back. I don't tell you something that it's not open to the public yet. So a different view we provide you is the functions overview. So if you have dependencies, libc is a common dependency, or OpenSSL is a common dependency that is shared between different applications, for example, to write HTTPS traffic or HTTP encrypted traffic, then you maybe see it once there in this application, maybe there in this application. And in this functions view, we give an overview, or we can tell you what are the functions that are called most across your stack. And I will try to zoom in a little bit more, because I think that's the super interesting part. We care about our environment, really. We want to reduce the CO2 footprint that make our applications. And here we can see the system that everything is running on here in Azure is spending the function that is most used on the system is a log function in the kernel. And it produces around 0.13 kilogram of CO2 in the last 30 minutes across all deployments, and it costs me $1.08. So what we are doing is basically we are there are public APIs basically for every cloud provider, where we fetch the information on how expensive computing is, and then we break it down and can tell you here, this is the analyzed dollar cost, this is the analyzed CO2 footprint. And I think that's super interesting to see, and that's what I wanted to go on. So I was clicking on the run side. Of course, we can also filter here. I think for me, at least for me, the filtering is more easy if I just click on the thing I want to filter for, and then go back. And here I can see also for the worker that is part of the OpenTelemetry deployment. He's doing some copy user stuff, copy user enhanced fast string. So there's some string handling happening. So I have no idea what the application or the OTel application is doing, but obviously I'm spending a lot of money on string handling. And I want to compare it, to be honest, because I know that there's, as we saw earlier, there's a worker 0 and there's a worker 1. And I want to compare it. And for this, we have the differential top end view. And I just change here. Here the comparison function. So we can also, you can say, hey, I want to compare deployments, or want to compare nodes, want to compare something, whatever you like. That's really up to you. In this case, I just compare the processes. both processes in the last 30 minutes. I can compare worker 1 with against worker 0 for the last hour, but just for the demo, it's fine. But I already can tell, even without any traffic going on, we have a differentiation. So worker 1 against worker 0, there's a performance difference of 3%. This comes down to some kind of different CO2 footprint, and also the costs are different. So if the cost is not static but dynamic, one will be cheaper than the other, and that's super interesting to see here. Okay, and we can also do this for flamegraphs. So I didn't load too much. I will just increase the window a little bit. Okay, usually we show something down here, the differential flame graph. I don't know why it's not loading. Maybe because I'm zooming too much. I'm zooming too much. That's a pity. Sorry for the inconvenience. So we still have a flame graph in the differential flame graph view. And instead of colors, you see here a lot of gray stuff. And gray stuff means there's no changes. But if you zoom in, and that's unfortunately not possible with the current setup, you will see parts in red and in green. Green usually means something improved. Red means something was not performing well against the other side. I don't know why I cannot do this at the moment at this screen scale, but I think you can get or can have an idea what we can show you here. Yeah, I think what is also super important to know is the storage exporter, the explorer, not exporter, and universal profiling will need some data, and with the storage explorer, we can give you an estimate how you have to scale or how you should provision your Elasticsearch backend, so it will so it can come up with the data. So in this case, I just have one node. Elasticsearch doesn't have problems with one node, but usually customers have bigger setups with hundreds or even thousands of hosts that are reporting. Then you have to scale a little bit different. And the Storage Explorer is a quite nice way to see, hey, where do I go and what are the expected stuff in the future. We can even break down the data even more. So everything is running since Friday. I have about 40% stack frames, samples, about 30% metrics, and stack traces. Yeah, that's roughly the idea. To keep a number, if I remember correctly, the data, so universal profiling is sending data from every endpoint basically to Elastic to the collector, and for this it's roughly about 30 megabyte per day per core, if I'm not wrong. So not too much. There is some data we sent out, but I think if you compare it to other stuff, other components sending out 30 megabyte per day per core is I think manageable nowadays in Kubernetes environments. Okay, and then we're roughly at the 25 minutes mark. Are there questions?